Suppose you're given an equation like 3x cubed plus 4x squared minus 2x minus 1, and you're asked to factor the equation. One method you can use is known as synthetic division. Synthetic division allows you to quickly check if a number is a factor of the above expression. To determine the possible factors, we use the rational factor theorem. We want to look at the factors of minus 1 and the factors of plus 3. We take the factors of minus 1, which are plus minus 1, put them in the numerator, and we take the factors of 3, which are plus minus 1 and plus minus 3, and put them in the denominator. This gives us the following possible roots. We could have 1 or minus 1. We could have 1/3 or minus 1/3. Hence, we have 4 possible roots that we need to check. We're going to check using synthetic division. Let's start with the first root, positive 1. First, we write the root. We make ourselves a rectangular box, and then we list all of the coefficients of our polynomial. It's important to ensure that we list every coefficient, even if one of the coefficients was 0. Now we follow the following pattern. The first number comes down, then the 1 and the 3 are multiplied together. 1 times 3 gives 3. Now we add the numbers down. 4 plus 3 is 7. And we multiply again by the 1. 1 times 7 is 7. We add the numbers down. Negative 2 plus 7 is 5. And again we multiply. Finally, negative 1 plus 5 gives us 4. This number here is not equal to 0. If it was equal to 0, we would know that 1 was a root. But since it was not, it has failed our test. We now move on to the next root. Again, the setup is the same. We bring down the 3. 3 times minus 1 is minus 3. 4 plus minus 3 is 1. 1 times minus 1 is minus 1. Minus 2 plus minus 1 is minus 3. Minus 1 times minus 3 is positive 3. And finally, minus 1 plus 3 is positive 2. Again here, positive 2 is not equal to 0, so minus 1 is not a root. Let's check 1/3. Again, we follow the same pattern. The 3 comes down. 1/3 times 3 is 1. And 4 plus 1 is 5. 1/3 times 5 is 5/3. Minus 2 is minus 1/3. 1/3 times minus 1/3 is minus 1/9. Subtract 1 is minus 10/9. Again, this is not equal to 0. Let's check our final possible root of minus 1/3. We bring down the 3, and minus 1/3 times 3 is minus 1. 4 plus minus 1 is 3. Minus 1/3 times 3 is minus 1. Minus 2 plus minus 1 is minus 3. Minus 1/3 times minus 3 gives positive 1. And minus 1 plus positive 1 gives 0. Alright, we finally have our final number equal to 0. This means that minus 1/3 is a root, and our reduced polynomial will look as follows. Since it's a root, we know that x minus 1/3 will be a root, and the remaining polynomial is 3x squared plus 3x minus 3. The way we know that is the 3 here corresponds to the 3 in front of the x squared. The 3 here corresponds to the 3 in front of the x, and the minus 3 corresponds to the minus 3 here. We could continue with this new polynomial we have here and attempt to factor it further. However, in this case, if you look at the discriminant, you'll find that this is an irreducible polynomial. This is irreducible. Hence, what we have here is our fully factored polynomial. Thanks for watching.